start of the NC500 at Inverness is on a geological fault you can see from space. The Great Glen Fault, the memory of when continental plates slowly collided nearly 500 million years ago, and it is that collision that has shaped much of the geology of this part of Scotland, and has also made it unique in the world and a fascinating subject. The Great Glen Fault runs from north of Shetland down, dividing Scotland, and then onto Ireland, with the north of the country slipping past the south very, very slowly, and is possibly as deep as the Earth's crust. It's also very old, so not very active, unlike the San Andreas Fault made famous by its frequent shocks and pretty cheesy movies. Loch Ness is not formed by rivers or glaciers, it is literally a crack in the earth, 270 metres deep. To put that into context, it's over 200 metres deeper than the seas surrounding Scotland. Yeah, deep enough to hide a whole shoal of monsters. And you can hide Canary Wharf and Britain's tallest skyscraper in it. And it divides the country geologically, with very different rocks north and south of the loch. You may choose to do the NC500 in the very north of Scotland to enjoy the views, or spend a few nights camping out battling the midges, but the geology of this part of the world is completely insane, and with some of the facts and figures, mind-bending. But having an insight into the forces that crafted this landscape is certainly interesting. I can only scratch the surface of this topic, given the complexities and my limited knowledge, and at the very least you can enjoy the views I filmed as I travelled. To assist in converting deep geological time into something you can get your head around, I'm going to use the NC500 as a guide. Every mile represents 10 million years, so 450 miles represents the creation of the Earth and the solar system, and if we're going anti-clockwise, then it gets us this far. To put that into context, if we start at Inverness Castle, walking just 1 metre is all of humanity's civilization. Getting to the road down the drive is the history of Homo sapiens. Making it as far as the High Street is about 2.5 million years, and marks a period of several ice ages lasting up to 100,000 years, with short interglacial periods like the one we're currently in. It's called the Pleistocene, which makes me think of Morph, which shows at my age. I have colour-coded the main geological periods, although not all are relevant to northern Scottish geology. But as you can see, when we get to 50 miles away, there's not many periods, but more on that later. The geopark is found in the north and west of the route, but there's a few things to see on our trip anti-clockwise north. The most striking things when you come to Cromarty Firth are the oil rigs, lined up waiting for repairs or decommissioning. This long sea loch is in fact a fjord. A great glacier swept down to carve out the valley, and as it carved it dug the floor deeper than the sea beyond the 2 points called the Suitors, a narrow exit being a feature of a fjord. Cromarty was home to the Victorian paleontologist Hugh Miller, who lived in the first half of the 19th century. South Tor, he collected fish fossils from the nearby cliffs, conglomerates, a strata of petals cemented together that also contained nodules with fossils from the Jurassic period. Hugh was a devout Christian and wrestled with his fundamentalism and his love of fossils. There is a museum in Cromarty to his work and a trail. The Nig Energy wind turbine builders, you can see, built the towers and turbines for the Beatrice wind farm. It's about 8 miles out to sea, and it's on the site of an abandoned oil field. One of the few closer North Sea oil fields, the oil being piped in along the seabed to Cromarty Firth. The sandstone the oil is found in is much younger, Jurassic, and it's worth noting oil is not found in some subterranean lake, but in porous rock. The same Jurassic rock can be found above sea level along the coast at the Suitors. Jurassic rocks are some of the youngest geology on the route, a period best known for dinosaurs of course. On our map it's 14 miles to 20 miles from the start, or 60 million years, ending at Muir of Ord and extending back in time to Dingwall. Heading north to Fleet, as we go further from the mountains, no great glacier carved out this valley, the hundreds of metres of thick ice 20,000 years ago being more of an ice sheet, with the valley being created by erosion, meltwaters and rivers. The sea loch is a bar estuary, the sediment being formed into sand spits. The mountains inland are granite intrusions, from 480 to 420 million years ago, when the collision of continents not only created mountains, known as the Caledonian orogeny, which in Latin simply means creation of mountains, but also thinned the seabed. Molten lava then bubbled up into the crust and cooled slowly, the softer rocks above eroding away to reveal these bald mountains. This period in our NC500 time machine takes us to Tain. As we head along the coast, these ancient granite mountains became islands, surrounded by Devonian red sandstone, deserts, shallow lakes and seas. When we get up to Caithness, we can clearly see we are on Devonian red sandstone. The sand and gravels eroded from the Great Caledonian mountain range, and those shallow seas and lakes were full of early fish, strange alien-looking creatures, and there are plenty of places to go hunting fossils. Go off the beaten track and take a small detour, and there is a dedicated fossil hunting spot, the Arcanaris Quarry, long abandoned, where they turn over the stones with diggers, so you can spend a few hours seeing if there are plenty of fossilized fish in an ancient sea, and there's also information boards on what to look for. All this flat, featureless landscape means the wind blows steady and strong, and an ideal place for wind turbines, and seeing this is a road trip, a chance to bang out some road trip tunes. Layer after layer of sands were either blown or washed down into shallow seas, lakes and deserts, making excellent paving slabs, quarried and exported all over the world. And because it came after the Great Mountain building 500 million years ago, and because there's been no crashing of continents nearby, and no subsequent mountain building, or mountains close enough to send glaciers over the last 2.5 million years, the strata is found in level layers, although there is twisting and buckling you would expect over 400 million years. And some erosion by rivers, and the seas forming stunning coastlines. Arches and towers. Although exploring the coastline along Caithness is not easy, I have used the nearby cliffs of Orkney to illustrate this geology, and a chance to get a selfie. For the last few million years, the North Sea has only been around in interglacial periods, but its power and the structure of the rock allows for spectacular arches and stacks, and sea caves, where on this occasion the roof collapsed, creating this gorge. As I mentioned, this sandstone is from the Devonian period, and it may be noticed that many geological science names are related to Britain. Silurian, and not the Doctor Who foes, and Ordovician and Cambrian are names of British tribes the Romans encountered. And these tribal regional names were then adopted according to their specific geology. Ordovician relates to the volcanic geology found around Snowdonia, a period of volcanoes, and as British geologists did the early research, they got to name the discoveries, which was after the local Celtic tribe. British and importantly Scottish geologists were world leaders in the science over the last 200 years. One of the first was the English mining surveyor William Smith, who around 1800, after an amazing detective story found empirically that fossils were a highly effective means of distinguishing between otherwise similar formations of the landscape. As he travelled the country working on the canal system, he produced the first geological map of Britain. The fossil record helps us to understand geology and evolution. This seal's great ancestor 23 million years ago most likely shared a common ancestor with bears, an otter-like creature that adapted over millions of years to live in salt water. Thurso was the centre of exporting Caithness flagstones around the world. A great place to go hunting fossilised fish is the cliffs east of the town near the castle. As we head west, we pass Dunray, a major research centre of nuclear, which access the energy created in exploding stars a couple of billion years before our solar system was born, uranium being a long-lasting but unstable element. But humanity's impact on the planet has led some geologists to create a new geological age, the Anthropocene. The old reactors, nuclear waste, including plutonium that's not found naturally, will be part of the future geological record, as well as billions of tons of concrete, a synthetic rock we create, as well as a thin oily layer in the strata, which will be our discarded plastics and lifestyle, as well as a sudden drop in the fossil record. As you can see from field walls and buildings, the geology impacts humans in a more practical way. As we drive from Caithness to Sutherland, so the landscape changes. There are mountains and the geology changes too. The first hills and mountains you see are igneous, the lava that bubbled up when the crust was thin to form these granite mountains from the Ordovician period. But when we get to Betty Hill, the rocks change again. The mountains are taller, they are older, and you won't find fossils in these rocks, in these mountains. It's called the Moyne Supergroup, a collection of different rocks, initially sediment in a shallow sea laid 1 billion years ago, then added to in a deep ocean around 650 to 500 million years ago. In the late Precambrian period, our time machine route would place this period around poles. They were then dragged down deep into the Earth's crust to metamorphise under heat and pressure. Between 480 and 420 million years ago, 3 continents collided here. There is the continent that held South Scotland and the rest of Britain, the continent that held Norway, the Baltic and this part of Scotland, as well as the Northwest, which has more in common with Greenland and North America. This collision is the same speed as India currently crashing into Asia, pushing up the Himalayas, about 5 centimeters a year. During this continental crash, the mountains were formed, a huge range as tall as any Great Range we find today, and they are the same mountain range that is found in Norway, and because all of this happened before there was an Atlantic Ocean, the mountain range is also found in Canada, in Nova Scotia, New Scotland, and the Appalachian Mountains, reaching down into southern United States. Burnhope is the most northerly Munro. Munro is a classification named after Hugh Munro, meaning it's over 3,000 feet. A little off the beaten track, just beyond Lockhope, is an Iron Age rock. The exposed strata on the western slopes and more gentle eastern slopes is an illustration of the power of colliding tectonic plates, like some ancient car crash that have pushed up rocks exposing the underlying strata. These are known as Moyne schists. It is when we get to Loch Erebor that the geopark starts, and many of the laybys are marked with a route symbol and have information about the local landscape. On the westerly shore of the loch is gleaming quartzite, very different to the metamorphized rock of the mountains on the east, because they were once separate. This is another fault line. About 100 million years before the Great Collision, the western edge was a shallow sea of white sand, on the edge of a long-lost continent, and it's been compacted and cemented into this gleaming rock. Quartz is very common. It's silicon dioxide, and it's very tough, and it comes in different colours like tiger's eye and amethyst, and makes up most of the semi-precious stones. It doesn't erode so quickly to dust like some other rocks, and so we have white sands, mainly quartz, and then those beaches were submerged with rising seas, and ocean sediments rich in bones and shells of sea creatures formed into limestone along with mudstone, and again pushed up during the Caledonian mountain building period, and under that pressure and timescale, the sands become quartzite rock. Most of the limestone has eroded away here, but a little further on, at Durness, the limestone remains. You can see the farmland is that bit greener, and this is to do with the geology. Dolliston and the limestone rocks that were deposited along the margins of the Iapetus Ocean during the Cambrian and Ordovician period, and when this landmass was well south of the equator. and here there are a few fossils. Sea creatures like sponges, although rare, and pipe rock. Limestone with a burrowing of worms through it has been preserved for almost 500 million years. Limestone can quickly dissolve, the more acid streams creating limestone pavements and swallow holes and caves, the most famous being Smoo Cave. Vikings used this as a little harbour and workshop, and if you're a gaming fan you can imagine a scene from Skyrim with boat building and maintenance. But the Vikings were also drawn to the area for its fertility. Plants like are fairly neutral to alkaline soil. The thin soils of granite are acid. This tiny area has 2 faults running through it, and 5 different rock types, all in a very short length of coastline. The proximity of faults and the huge forces at work have created unique rocks like the oyster shell rock dating from the Ordovician period, making it a very interesting geological corner in the world. As we crossed over this fault, that runs north and south, so the landscape changes again, as does the rocks. We take a detour to Old Shoremore Beach. These are called pebbles on the Geopark. The road you travel on is recent, built in the 1940s. Once the crofters here had to go by sea to travel anywhere. Set back from this beautiful beach is an outcrop of rock quite different to the surrounding bedrock. It's Turidian sandstone, and we're encountered as mountains further south. Just as southern England was covered in the shallow seas during the Cretaceous period, forming deep chalk formations, Cretaceous means chalk, 145 to 66 million years ago, so was the low-lying north of Scotland. In the later period, about 75 million years ago, a tropical sea submerged Scotland once more, except its very highest areas. Thick layers of chalk were deposited on the seafloor, but little evidence is seen of this chalk today, as much has since been eroded away. By the end of the Cretaceous, much of the huge Caledonian mountain range had been reduced to a landscape of low relief near to sea level. The next information site on the Geotrail reveals glacial erratics, boulders dotted around the landscape, but of different parent rock. These are granite from mountains many tens of miles away. They are dotted all over this west coast, picked up 20,000 years ago by ice sheets, which in geological terms is a blink in a planetary eye, and rounded and smoothed like huge beach pebbles, a game of marbles by the ice gods. Their location is where retreating ice sheets drop them, and this helps geologists map the course of ice flows. Legend has it that the Scottish Northwest Highlands is where the Norse gods practiced their mountain building skills before they created Norway. The rocks here are Luasian gneiss, which is 3 billion years old, formed as igneous rock in the Earth's crust. The same rock is found in Greenland and parts of Canada, and it was here Scottish geologists made the physical connection. North America, Greenland, and here were once connected, and it is this geological detective work that led to an understanding of plate tectonics, crusts sitting on hot magma. Some of the gneiss in Greenland is older, 3.8 billion years old, but 3 billion is insanely ancient. On our road map time machine, the beginning of Earth and the solar system is here. This part of Scotland was formed here, and the Atlantic only started its life at this point, way back here. Travelling south among these incredibly ancient hills, we are travelling in an alien landscape. Where the road building has cut into the rock, we get to see the crazy nature of Luasian gneiss. Black, white and pink, the vertical lines are where the road builders drilled into the rock to cut it away. The Geopark calls it the multicoloured rock stop, and it's near Laxford Bridge. Evidently one of the team of geologists setting up the park grew up watching 80s Saturday morning TV. Gneiss was formed 25 kilometres underground, magma that cooled producing crystals, and then twisted and bent and folded like Play-Doh over billions of years. 3 different ages of rock can be distinguished here. The pale grey gneiss represents the original rock into which once molten sheets of black basaltic magma were later forced. The streaks of pink granite must be the younger of the 3 rocks, since they can be seen cutting through both of the older types. As you can see, the actions of erosion compete with mountain building and volcanic action. The world is constantly recycling itself, although the ancient gneiss escaped being dragged back down into the mantle to be melted down. But elsewhere it was pushed up into mountains and eroded and washed and blown down into plains as sand, silt and clay, and deposited as sediments in shallow seas, which over hundreds of millions of years would be compressed into new rock and pushed into new mountains to be eroded back into sand. There are a number of short routes off the Geotrail called pebbles. Here, looking south, are the mountains, or Inselbergs, meaning island mountains. It's a word used by geologists to describe these strange isolated peaks, made from Pteridian sandstone and laid down as sand in rivers some billion years ago, and it starts to become the dominant rock for this section of the journey. Erosion during many ice ages has exposed and carved them to create this unforgettable and distinctive scenery we see today. The highest Geopark peaks are capped with pale grey Cambrian quartzite, a rock that's harder than the sandstone, so it withstands erosion better. These quartzite caps have been protecting the sandstone below. At Annapol is the Rock Stop Cafe, a dramatic example of the power of tectonic plate movements, and a mystery come controversy. And to really appreciate the geology, don't do it in the morning when the shadow obscures the mountain strata. Wait until after the sun has passed. This is the Glencoe Thrust. Lewis and Gneiss forms the upper slopes of the hill, and this has been thrust over the Erebol Formation of quartz, which is from the Cambrian period, that forms a prominent cliff line. Ancient gneiss above and below, supposedly much younger quartzite. The controversy? The Highland controversy, to be precise, was whether the rocks had been incorrectly aged or some other process. The solution to this mystery emerged just over a century ago, and we'll come to that later. And we head towards the coast, and the stunning coastline of billion-year-old Tellurian sandstone that, like the youngest Devonian sandstone, is easily carved by waves to form the stunning stack of the Old Man of Stoer. Unlike the sand of the east coast, the strata varies greatly in thickness and composition. Instead of fine grains of sand cemented together suitable for flagstones, the sandstone is coarse and sometimes more like pebblestone. Ancient riverbeds and valleys carved billions of years ago, filled in a billion years ago with sand and gravel, and then in more recent geological times eroded to reveal the former ancient alien landscape. The geopark contains the earliest evidence of life to be found anywhere in Europe. These simple-celled algal lifeforms occur in these sandstone rock strata and are dated to 1.2 billion years ago. However, geologists call this huge period of time the Boring Billion, a billion years between 800 million years ago and 1.8 billion years ago, that saw early simple life evolutionary stagnate and little hardcore geological action. Attersent and Knock and Crag above became the subject of much debate when geologists noted Des Moines schists at the top of the crag appeared to be older than the Cambrian and Ordovician rocks such as Durnas limestone lower down. Disagreement over the processes that could have caused this to occur were referred to at the time as the Highland Controversy. The mystery was finally resolved by the work of Ben Peach and John Horn in 1907. There is a memorial to their pioneering efforts. Peach and Horn demonstrated that the situation resulted from the action of a thrust fault, this being the first to be discovered anywhere in the world. The older rocks had been moved some 70 kilometers to the west over the top of the younger rocks due to tectonic action. Like a pack of cards being shuffled, with the force of colliding continents pushing strata underneath older rocks. The next geostop has a feature that can be measured in thousands of years rather than half a billion. The little hummocks in this classic glacial U-shaped valley are called moraine. An accumulation of unconsolidated debris, glacial till, is the ground-up rocks the glacier carried and then dumped when the ice melted. Occasionally there's enough debris dumped at the end of a glacier, a terminal moraine, to dam the valley and create a lake. At the delightfully named village of Elphin, the green fields indicate we are back on the limestone, and the fault line that connects Elphin to Durness. Between Elphin and Arvrek Castle are the bone limestone caves. The geologists, Peach and Horn, excavated the caves, finding remains of animals that once roamed the highlands. They include lynx, polar bears, Arctic fox and lemmings, and traces of humans who hunted or were hunted by them. The grooves you see cut into the valley slope were not carved by water, but again by the actions of a glacier, carrying rocks in the ice like a giant sandpaper scratching away. The geopark officially comes to an end near Alapur, but a few miles on is the Corrie Gorge, where you can see recent geological actions caused by rapid meltwater from retreating glaciers just 12,000 years ago. The power of water found a crack in the ancient Moyen bedrock and carved out this mile-long, 60-metre deep feature. We started the journey with a deeply cut sea loch at Cromarty, the Vikings knew as fjords. These shallow sea lochs on the west coast also have a Viking name, fjords, although in Viking fjord and fjord meant the same thing, a sailable body of water. And so our 3 billion years of time travel comes to an end, although a detour to the Isle of Skye and the insane geology and dinosaur footprints are well worth a visit. And there's a link to the video of that in the description. And I hope you enjoyed the trip. Do comment, like and subscribe, and I hope you see any future trip you make on the NC500 with fresh eyes looking on an ancient landscape. There is plenty more to explore, and I will return.